Hello, welcome to another Ask an Expert session at the European Environment Agency. My name is Gülçin Karadeniz, and today we are going to talk about Copernicus in situ and air quality, air pollution. I'm joined by two colleagues, Ragnhilde Finnsbjørnsdottir, if my Icelandic is a bit rusty, and Jose Miguel Rubio. Can you just say a few words about what you work on, what you worked on?
Yes, thank you. It's very nice to get the opportunity to be here with you today. Here at the agency I recently joined, I work as an air quality data expert here, where I kind of assist European countries to report their air quality data, which they should report every year according to air quality directives. But in my previous position in Iceland, I worked at the Environment Agency of Iceland, actually at the other side of the table as an air quality data expert, where I did the air quality reporting for Iceland. So from there I have some experience in actually setting up measurement stations for air pollution.
Hands-on kind of experience.
Yes, a lot. So kind of I talk about it a little bit from cradle to grave in that sense, from setting up the stations all the way down to making the assessments of the air quality data at the other end.
So now you're going to look at the bigger European picture.
Yes.
Jose Miguel, can you say a few words about what you work on?
Thanks a lot. I'm actually working at the Copernicus team here at the agency since 2 years ago. Although I joined the agency 7 years ago. I'm responsible for what we call the Copernicus in situ component. Yes.
What is Copernicus and what is in situ? Can you just please expand that a little bit?
Yeah, Copernicus is the European Union Earth Observation Program, which is providing free and fully open access to data and products about the environment and climate, building on a constellation of satellites and in situ data.
And what is in situ?
In situ, which actually is a Latin word, which means on site or locally, actually refers to measurements that are made on the ground. For example, with air quality monitoring stations or sensors placed on ships, for example, on balloons, or for example, by the rivers. Or we also, in the context of the Copernicus program, we also refer to topographic maps or ancillary data, like, for example, administrative boundaries that you cannot observe from the sky.
Okay. It also serves as a kind of a verification mechanism, yes. Doesn't it?
Yes. In the context of the Copernicus program, in general, in any kind of Earth observation program or activity, in situ data is typically used for quality control. The products that we create with satellite observations is also used to validate these products because we can obtain data on the ground that you can then compare to what you observe from the sky, let's say, from the satellites. And it can also serve to obtain information that you cannot obtain in the satellite through satellite observations. For example, distinguishing very similar type of crops, or for example, obtaining the names of rivers, or for example, how it is used certain pathway, whether it is public, private, all this kind of things.
It's amazing what we can actually see from satellites, but it does require some verification. Our focus is on air quality, so how does the work that we do in situ and this kind of data collection on air pollution, how does it fit into our work?
Yeah, I can.
Maybe you start, and then
I can start more from the connection to the Copernicus in situ, and then I can give you the word. As you said before, and as I mentioned, we need data on the ground to verify, to quality control the observations that we made via satellite. In particular, the EEA with its network, the IONET, we're having this network of air quality monitoring stations all over Europe, and this information is then passed on, all the data that we are collecting in these stations, to our colleagues in the European Center for Medium Range Weather Forecasts, which is one of the institutions implementing the Copernicus program, particularly the Copernicus Atmospheric Monitoring Service. This data that we produced together with our members is passed to them, and then they use it typically to improve their forecasts about air quality. It's what we call assimilation. They include it into their models, and also as well they use it for validating the model, and also to, let's say, over time reconstruct the past, how the situation of the atmosphere was in the past as well.
We'll delve more into it, but before actually I pass the word to you, this is a live chat, and
Sure.
we are here to actually answer questions from our live audience. So if you do have questions, please do post them on the comment section, and the team will forward, and I will ask them on your behalf. So back to the air pollution question. How does that work? Why should we monitor air quality first before we look at the data, Charlie?
That's a good question, and I find this very interesting discussion, how we can connect the air quality data we collect here at the agency with not only by doing some data assimilation by informing the public on the status of air quality in Europe, but also how we can use the data in the context of Copernicus and how these kind of two different data sets help each other out and make the one of the aims we always strive for is to have better information and more accurate information to give to the public. Am I right? So, of course, most people know that air pollution is quite harmful for human health. We have seen various studies that link increased air pollution to both not only increased mortality, but also increased morbidity in different kind of sense, like increased hospitalization due to respiratory disease, heart disease, and so on. So this is quite commonly known. And for this reason, we have air quality directives where they say that we need to monitor air pollution, especially where people are exposed to the air pollution. So every year, the European countries have to report the air quality they measure in their countries to EEA, so we can actually assess how the status of air pollution is in Europe and see if the countries are doing a good job in decreasing their air pollution to look out for human health, and not only human health but also environmental health.
Mm-hmm. How does it work though on the ground? I mean, it was like when I cycle to work, I do see these boxes, let's say, that measure.
Right.
How does it work, from the way that these monitoring spots are selected and set up, and what do they report on? Is it automatic reporting? Maybe you could just explain a little bit.
Yes. I can give you my experience, for example, from Iceland. And it's nice that you actually sometimes notice this, because I don't think everybody know what these kind of boxes are. You sometimes see with some kind of strange inlets. But actually in the directive, and we have guidelines on how to choose the location for these monitoring sites. And that actually depends on what we want to monitor. Is it the traffic pollution, urban pollution in general, or background pollution? And for example, maybe also in the context of Iceland and all of the volcanoes that are there.
Oh my gosh.
Yes, indeed.
We often have to jump and, if there's an Icelandic eruption in Iceland, we have to put up a measurement station in, a general close proximity to the eruption.
Hopefully not too close.
Not too close, so we need to watch out. And we want to, of course, try to monitor the main pollutant from the volcanic eruptions in Iceland, which can be greatly and extremely high concentrations of SO2, sulfur dioxide, or even particulate matter. So that's generally how we choose a location. At least we try to use the directive and do the minimum of what the directives say we need to do. And then when we've set up the station, we need to get the streaming of the data online, so we can inform the public what's going on.
Is it like every hour that these things are just...
Yes, mostly. We try to, that's the prime, I would say, time resolution. So you can imagine we get, in only Iceland, we have around 41 measuring stations. But I know countries that go over 600 stations in just one country. And then we get, in one station, you can measure from 1 up to 5 to 10 pollutants at every hour. So it's an extreme amount of data we get from all of the countries every year on the status of the air quality in their locations.
And then that quality is aggregated before it's reported.
Yes, of course we do, both the countries do some quality checks and quality assurance before they send the data to us. And then here at the agency, we also do some quality checks. And also we give out, once a year, we give out the status of air quality in Europe, which is aimed to be published, the new one in June. We want to give this information to the public and inform the public of the status. So we try to do that in various ways. For example, with that report, and also we have the air quality index, which is online on our homepage.
We can actually share some of the links in the comments.
And
we
also
have some questions coming in.
Oh,
Sorry for
great.
interrupting,
Yes.
but actually it's some of the points that you're raising, so I want to just ask them so that we cover them. There's a question from, many questions coming in. There's a question from Paula. We'll take that one first. How accurate is current air pollution monitoring, and what other technologies can be used to monitor air pollution? Could we possibly use drones in the future? There are some balloons and
Yes,
things.
that's
so
a
these
good
are like the
question.
prototypes of these things.
Yes. So first of all, the accuracy. The accuracy it should be quite good, and we state this in the guidelines of the directives how they should be quality checked. So the accuracy from the country should be quite good. And additionally, then we at the EEA do some quality checks as well. So they should be quite accurate, at least the verified data that the nations or countries send to us. The up-to-date data can, on the other hand, sometimes include some errors, of course, because it's often difficult to monitor the data whole 24 hours, 365 days out of the year. So sometimes we get, but that should be corrected in the end, and we ask the countries to do that. And what other measures can be done to measure? Well, actually, I know that in harbors, some countries have been using drones to go in the plume from the ships when they're coming into the harbors to actually measure if they're using...
because there are some sulfur...
Yes,
whatever.
compounds,
Yeah,
yes.
because there are also some areas around the harbors that have that kind of limitation, right?
Yes, there are some bans for some specific types of fuels within the harbors. This is not exactly my area expertise, but I know that some countries use drones. And then one of the cheapest way would be, if we come back to ambient air quality, is to have these passive samplers you can set up. They're very cheap, just like small tubes. You can set them up all around. I know some schools do this with the students. And then, well, the main cost would be to analyze the sample, the tube at the end. Yeah.
Well, we are getting many questions, so I want to just kind of go through these questions. There's one on the health aspects, but before we get to the health impacts of this, I think there's a kind of related question from Adil, who's an air quality engineer. How about the calibration of the stations? Are the solutions reliable? You were saying. Is calibration when the satellite information and the in-situ information are kind of connected? How does that work?
Well, I think there are two things here.
Yes.
One is the calibration of the station, which I am not very familiar, but I guess they follow a very strict reference process to be able then to be used as a reference station.
Yes.
And then there are the connection with the satellite. There are what we call some measurements, in situ measurements, that we call fiducial reference measurements. They are very, very precise, well-characterized measurements that we need to use in order to calibrate and validate the images, the sensors. the raw data that we obtain from the satellites, as well as the second levels of products from the satellites. And these are really very, very well characterized, very accurate measurements that can be used then for calibrating the sensors which are on board of satellites.
Mm-hmm. I think there's a kind of a nice follow-up question from Emmanuel. So he says, hello, so CAMS, Copernicus Atmospheric Monitoring Service, uses already the data from in-situ sensors on their models. What are your recommendations if you want to include data from other in-situ sensors that are not included in the current models? And he says data fusion question mark.
Here, of course, the European Environment Agency is not in charge of the Copernicus Atmosphere Monitoring Service, so I cannot really go into details.
It's ECMWF.
Exactly, so I would not really like to enter there, but of course there is a wide range of in situ data from networks, not only in Europe, but all over the world, because they are offering a global service that is being used already, included in their models and validating their models in order to provide a consistent and high quality information. Of course, they do have their protocols and the ways to introduce more information whenever it's needed, but that's something that is more up to them to reply. Of course, the listener can always go to the...
But we can actually say that these models have been improving significantly with this kind of data availability over the last decades and so on and so forth. I mean, this is
and they are continuously improved, because the measurements that we, thanks to in this case to the air quality monitoring station network in Europe, but also other networks, they use this continuously in order to improve their models and hence to improve the forecasts, and also to what we call reanalyze, which is the reanalysis, which is actually to improve the knowledge that we have from the past. The past situations of the atmosphere.
Well, we'll stay on the air quality data and monitoring and so on and so forth. There's a question from Arijit, but in the meantime, if you just joined us recently, you can post your questions in the comment section, and I'll be asking your questions to my colleagues here. But Arijit is asking, is there a possibility of acquiring air quality data in mobility using public transport and low precision sensors, and then validating the data using Copernicus satellite data? I think there were some things about, at least I've seen like the kind of devices that you were mentioning, that if you're cycling to work kind of thing, so you could have one of these little sensors.
Personal sensors, yes. There are many options in that regard. And the person can choose to use that and see how
they're exposed.
They're exposed, yes, exactly. But actually, those sensors, they're usually not, and I mean, I think that's a given, that they're not as accurate and dependable as the big monitoring stations we have, which follow specific guidelines and actually use reference methods to measure the data. But it can give you an idea if you have like a personalized sensor on you, if there's increased pollution around you or not. So
if you're suffering from asthma, let's say, maybe this is something that you could try to at least have an idea of your exposure. Maybe.
Yes.
Well, we are at that actually. The first question that we received from Aiche is there any report we could find some health-related studies showing the relation between ultrafine particles versus health impacts? And she says, thank you for your answer.
Okay.
Yes, we do have some health-related things, but maybe you could just expand on it.
We have a lot of studies that show there are different types of particulate matter, from PM10, which are one of the coarsest or biggest particles in the air, down to PM 2.5, which are even smaller, and ultrafine particles, which are really, really small.
So this is really the size, the microns, and the number indicates the size of the floating little...
Exactly, and they're like floating particles in the air, which we can't, they're so small we can't see them. And since they are so small, especially ultrafine and black carbon, they can actually enter your lungs, and studies show that they can even enter the bloodstream. So usually the scientists or the academia talks about that the finer the particles, the more adverse health effects they can actually impose to human health. And this is something, there's upcoming a new directive where the ultrafine particles are mentioned, and there will be a requirement if it goes through. There's an election later this year on the new directive. They state that ultrafine particles should be measured, which was not a requirement up until now. So this is something that scientists know that has adverse health effects, and hopefully we will monitor this in more extent. And when we monitor it up to a more extent, we can do more research on it. Yeah. Mm-hmm.
There's actually a kind of a nice question from Rossana Filippini. In your experience, is Copernicus, etc., monitoring results are they helping to influence the implementation of more effective environmental policies, at least here in the EU? This is the kind of legislative, I would say, additional, benefits that, like a proposal on the fine particulate matters might be resulting. So can you just say how that kind of knowledge helps improve environment policy? At least the air quality has been improving, that we can say.
Yes.
I would think so, right, Jose? At least mapping and modeling of air pollution, that has helped a great deal. And that often shows, for example, some hotspots people didn't realize were there before, and so on. At least I would say that in the Icelandic sense, that would be the case.
Yeah, definitely. Definitely, Copernicus being a free and open data products program, let's say, it makes possible for the results to be shared, to provide input to the implementation, to the development of new legislative instruments in the domain of environmental and climate. We are now focusing here on the atmosphere, but we have to remember as well the Copernicus program is bigger than atmosphere. We are covering climate, we are covering the oceans, we are covering land.
Yeah, which we are responsible for.
Where the EEA has a very important role, and there we are also seeing a very important input that we are given, thanks to our products, into current and new legislation which is on the pipeline now.
And maybe if I would just add, I mean, using Copernicus and open source material, I mean, that just is beneficial for the academia and, researchers to use.
And local administration as well, because I think one of the air legislation does aim to limit exposure and informing the citizens of different, episodes of high peaks and so on and so forth. So in that sense, we can say, yes, Rossano, it does influence. And then some of the results do indicate that. Moving on, we have a question from Georgia. We have still a few minutes, so I want to take as many questions as possible. What about air quality maps? Yes, this is something that we work on. We can daily find on Apple's weather app, for instance. Are they validated by the EEA? Do we know where such forecasts come from? I don't know where the Apple ones come from, but we do have our air quality index.
Yes.
Maybe you can say a few words about that.
We have our own actually air quality index also, and the air quality index app as well.
Yes, we can share the links to.
Yes, everybody can download and use, and there we use the actually up-to-date air quality data that the European countries report to us. But it's the same with me. I'm not quite sure where the Apple index gets their data. I think it's a combination of different sources. But I find it can be quite informative and give you an idea of how the air quality is around you. But yes, I would definitely have a look at our air quality index and
this is the kind of live hourly reporting that you were mentioning, so
Yes.
you can get the latest semi-validated, at least official reporting.
Yes, that's the up-to-date data we have on our homepage.
Yes.
Yeah. Moving on, Aiche again says, thanks indeed. The aviation airport business, we are really interested in very, very low particulate matter, even PM1, she says. We have a follow-up. We did talk a little bit about ports, but I can see the aviation sector and airport and stuff, and I know many airports do strive to be sustainable, and air quality is one of the issues that they look at. Arijit is saying, thank you so much for answering the question. I think we calculate the drift between the measurement units and low precision sensors and calibrate accordingly. It may work. What is your thought on this? Do you have any thought on that?
No,
It's a
but
bit
I think
technical.
I think that's how it actually works in the process of calibration. We
Very good,
I mean,
because I'm not an air quality expert, definitely not.
But in general,
calibration.
in any kind of sensor which is measuring something, in order to calibrate it, we need to compare it to other sensor which is of high precision, let's say, no? And particularly in the context of air quality monitoring stations of our network, this is done in a very, very controlled manner. But of course, this can be done for any kind of sensor.
Yes.
Yeah. Thank you. Thank you. At least clarifying that. We have just a few minutes left, and I want to give the floor to you two again. And is there anything else that we can actually share with our viewers? Like, what can they do? Where can they find information, let's say, on air quality and on Copernicus in situ, and get more insights? Maybe we
well, I can start. Well, as I said before, the European Environment Agency is in charge of coordinating the in situ component.
So it's not just air quality; it's also in situ on-site.
I wanted to highlight our role there is to assist institutions like, for example, ECMWF, but as well the European Commission, or other institutions like, for example, Mercator-Océan, to get access to in situ data that they need for their work. They also do it themselves, but we also try to support them by, for example, engaging with key data provider networks, by providing or preparing licensing agreements, for example, or by providing a kind of a overview of in situ requirements, challenges, gaps, to fulfill their objectives in the context of the Copernicus program. I think the key message that I can pass now is that in situ component, of course, sometimes is a bit shadowed by the constellation of satellites, the sentinels that we have.
Right.
It's maybe more fascinating, it's more shiny, let's say, but it's essential for the success of the Copernicus program. And that, I think that's our key goal at the EEA, is to raise awareness about the value of this data. And we have an amazing example, which is our network of air quality monitoring stations. Of course, if someone wants to know more about the Copernicus program and the in situ in particular, they can always go to our in situ website. I guess we will put it on in the comments.
But I guess that's one of the main things, just to raise awareness for the public. And I've mentioned a few sites the general overview people can go to see the status of air quality and what they can do. I mean, many countries have their own air quality homepage where you can check your own country and see how it is there according to their authorities and so on. But I think just the main thing is to be aware that there is information out there, and I mean, especially if you're dealing with some kind of respiratory disease or something, then I think it's good to keep an eye out and see what how the air quality is.
We even have the health atlas, so the environmental health atlas that looks at noise pollution, air pollution. You can actually check, your place, so you can actually type in and then zoom in and then see how.
That's a very interesting.
So this is something that we can also share, and maybe one last thing. So there's a big event, Copernicus event, that is coming up.
Indeed, my colleagues from the Copernicus team are organizing the Copernicus Land General Assembly in Antwerp from the 3rd to the 5th of June. So if you are interested, of course, you can go and link and have a look at the link. You can register to participate.
Yes, parts of it will be streamed as well, so you don't have to travel to.
No.
So it is accessible. So thank you very much for answering these questions, and thank you for your questions. And we'll be back with other Ask an Experts, but all the information, we can share the links and you can just explore further. Thank you again.